So recording is online. So Andreas, please go ahead.
Thanks, Tom. Let's do the tech check first. I hope you can see my slides. Tom, I think you got an answer because nobody else is entitled to talk. Okay, so let's get going. So I'm presenting today a little talk I put together, as Tom said, to the last minute. And I think it has the longest title I ever used for one of my talks. So it's Modern Application Security Challenge and Opinionated Overview. And I'll explain in a second what that really means. But before I get going there, I'll just want to quickly introduce myself. So who is this guy here? I'm Andreas. I studied telematic in Graz a long time ago, specializing there also on IT security. I worked then in a research center in Vienna, where I focused on network security. And then I also did my PhD there on traffic analysis for botnet detection, which is, well, botnets are like a specific kind of malicious activity on the internet. And I'm now, after a few other stops, I'm now a director of PM at Dynatrace, and I'm focusing on application security. And without any further ado, let's explain to you what my title really means. And I quickly wanted to give you some background on why I chose this topic, because I felt that there is this general feeling that some magic technology will solve our application security problems out there. We just have to wait until it's invented, and then all the problems are gone, and we can live happily going forward. And I think we want to contradict that. And I'll get to this point during this slide. Before I do that, let me explain word by word what this topic here means today. So modern, with modern, I mean more or less cloud native application security challenges. What are application security challenges in this context? This is explicitly not about corporate IT security. So I will not be talking about phishing scams or any kind of, I don't know, all this kind of corporate stuff, Active Directory attacks and anything like that. I also will not be talking about what is called nation state attacks. So these are like the highly sophisticated attacks by some kind of secret service against another country, for example, because this by nature they are somewhat different from the majority of attacks out there, and I rather want to focus on the majority today. I'll try to give a few individual examples of what I mean, and I'll explicitly want to focus on the implications on software engineering, knowing that there are quite a few software engineers in the audience. So, looking at the subtitle there, what problems are we facing today? As I said, I want to focus on application security challenge in cloud native. I also want to give you like a bit of history and context of what is different in cloud native than it was before, and what is relevant from the past, at least a small short history, a summary that I can manage to do in this short time. Then, of course, I need to disclose that, I mean, machine learning and blockchain, I mean, that was pure bait, right? I mean, and I'm sure you fell for that. So machine learning potentially will help us with application security challenges, and I'll get to talk about artificial intelligence at the end. But blockchain, absolutely not. So there is no reason why blockchain should be of any use for application security. I'm not aware of any use case where it would be helpful there. But it has its part in this talk today, and I'll get to that as we move on. But I promised that I start with an opinion, right? So I feel that for a tangible talk, you need to throw out an opinion first, that we get something to discuss maybe afterwards. And I want to throw my opinion at you first. So my opinion is that what security really needs to solve is to institutionalize engineering scrutiny and support the human's limited ability to deal with complexity. And this is very much in contrast to what I hinted at before. So I'm opposing here that we just need to invent more tech and more detection approaches in order to solve application security. I think this is not going to happen. Well, and that's all, right? That's the whole opinion. And in order to basically show you what made me think that this is the right, that this is an opinion I wanted to defend here, let me give you some background. So let's start with something really, really simple. what motivates attackers? Why do they attack a cloud native application? There are actually many reasons, and there's even studies showing up to 20, 25 different kinds of motivations for attackers. I'll list a few here. So some of them are motivated by technical challenges, right? So they simply want to see if they can crack open this system over there, because they simply want to test their technical skills. Then there is adventure, right? Some of them are thrilled simply by attacking enterprise systems. Then there's personal interest. There were a few cases where students tried to change their university grades. So that's also a very strong incentive. And then there's resentment, also very, very popular. So former employees disgruntled with the company they were working for would probably want to simply delete data there in order to harm the company. But there's many, many more. But I mean, one obvious thing is missing here, and I'm sure that all of you have that in mind already. Of course, the most prominent reason is money. And this is what I want to talk about today, and that has some implications on some of the ideas I want to push forward. So let's talk about where's the money, right? So where, if attackers are incentivized by money, where is it coming from? Of course, it comes ultimately from some kind of victim, but in order to understand this as a whole, you need to understand that there is typically behind an attacker, there is what is called the cybercrime ecosystem. There's multiple studies, like I think that has been researched now since 15 years or so. And I put up one of the reports here by IBM, just shows a tiny bit of this very complex topic. But the one takeaway I want to give you here is that there is usually not the one attacker who is just a genius superstar who knows everything, but usually it's a guy who relies on other services or products. And those services or products he goes and buys somewhere. So for example, if I want to break into Tom's system, for example, I probably want some site where I can deploy some kind of server that controls my malware that I put on his laptop, right? So I need some infrastructure where this runs. And there is, of course, vendors out there that sell you that. And they give you some kind of service level agreements even. They tell you that this site won't be taken down even if some kind of government or other agency engages and tries that, because they give you like 99.9% uptime. Of course, that has a price, right? And then there's many other things. I don't want to go into the details of all. Just one I want to quickly mention there. There's what is called a money mule. Money mule is one of the low tech, low skill set roles, but it's still very important. Because as soon as you extort some money from somebody by basically blackmailing a company because I don't know, you have some data from them, you need somebody who brings the money from them to you, right? And that's a money mule. And that also takes quite a lot of credits of money that you earn via your malware campaigns or whatever. So that's important to know. It's important to understand that there is an ecosystem behind, and that an attacker motivated by money would only do so if he can earn more money by that than he spends for all the services and products that he needs in order to make that happen. So that opens up the idea of a thesis, right? So or a hypothesis. Attackers like it easy, right? So that's pretty much standard. So we need to make it harder. And if there is less money for more work, there will be less crime. So the whole idea is that I'm trying to explain in the following is, how can we raise the bar? Because I think it's absolutely not realistic to simply argue that we block all attackers. We can just make it harder for them to a point where some of them might give up, and for some of them maybe it's not a good income anymore. They simply stop. So moving on here. So this is a very standard model of how cybercrime works. But what does that have to do with cloud native in particular? So in order to explore that, we need to first understand what is cloud native. And I think everyone of us has its own definition in mind. So I picked the one from the Cloud Native Computing Foundation, from their charter, which I think can be considered an authoritative source. So what they say there is a cloud native environment is usually there to build and run scalable applications. So far, no surprise. And of course, make high impact changes frequently and predictably with minimal toil. So that's the environment we're operating in. And why is that special? So, I mean, when now looking at cloud native security challenges, why does that make a difference? I mean, so far, we didn't, even before cloud native, we didn't quite solve security, right? I mean, there were breaches every year, and probably the number of breaches doubled every year. So we cannot really consider that a solved issue, despite all efforts and tools that were put forward. And now we are getting to protect a massively complex system that changes constantly. I mean, hold on, that makes it harder for us, right? So that makes it harder for us, not for the attackers, right? That's not really, from the security guy's view, that's not really what we would want. That we wanted to move that in the other direction. So that's great, or rather great, right? It's not really good for us. So we gotta change the way we do security. And I'll explain in the following what I mean by that. So let me give you two examples of two incidents that happened in the recent past, and I'll start with Tesla. So Tesla had an issue that they accidentally exposed the Kubernetes console to the internet, and that wasn't password protected. And that caused, after a few more steps taken by the attacker, caused Tesla to run mining malware. And on top of that, gave attackers pretty privileged access to the Kubernetes environment, and that exposed sensitive telemetry information from, well, Tesla cars. So that's not good, right? Second example, Kubeflow. Kubeflow is an open source project that's very popular for machine learning tasks, and these run in Kubernetes. And it happened in April that apparently there was a suspicious Kubeflow image seen deployed on thousands of clusters. And upon closer inspection, it was found, well, it ran also malware that ran a crypto miner. So you can see here, I picked two examples that had to do with Kubernetes, of course, but also they also have to do with crypto mining. And that's not a coincidence. I mean, it's those two, they are examples, right? And in the if you abstract that a bit, what it allowed the attackers to do is run code and access data. So in principle, they could have done anything, right? So I mean, they had full access to the system. But what they decided to do was run a crypto miner. And why is that? Because it's low effort and highly profitable. And remember what I told you about the money mules before? None is needed here, because the result of the crypto mining is directly usable by the attacker. So you basically save on the costs there. And that's why they chose to do that. But the steps they took on the way, I mean, they could have done anything, right? I don't know, delete all the data or encrypt all the data, as often happens. I just want to underline here the technical problems that the cost are one thing. And the other thing is, okay, in this case, it was crypto mining, but it really doesn't really matter. So how can we fix the general issue here? So let's think about what enables these attacks. It's rather simple. It's bugs in code and bugs in configuration. And actually, I thought a bit about that while I wrote that, but I didn't find a really good other explanation of what could cause nowadays these kind of incidents other than these two. But when you think a bit more, of course, everything is code now. So in the end, configuration is also code. So in the end, it's bugs in code, right? And just remember, we're focusing here on software engineering. I don't need to say that there is no other means to exploit the system. There's social engineering, there is phishing and all kind of, but it's kind of out of scope here. I just want to underline here, we're looking at stuff that is under control of software engineers and that software engineers can do something against, right? So in this case, it's bugs in code. And I want to get rid of this kind of notion that there is something really special about security incidents. Because in the end, what enables security incidents are just very old-fashioned standard software bugs. So for example, no input validation, untested edge cases, or some kind of logic errors. So it's nothing that is really dramatically new and nothing that is that is not also seen in Q&A areas. So its security is not very much different in this regard, but it has other effects because it can be exploited. So let's look at how this usually happens. What does an attacker do when he attacks a system, and in case of Tesla, for example, then runs a miner? I've here very much simplified a model that is very popular from the Mitre organization. You can have a look at the link if you're interested. So basically, that's an explanation of what techniques and tactics attackers do have in order to be able to classify these kind of attacks, and in order to understand them better and develop countermeasures. So this is a very much simplified model here, but it's not. It's correct, right? So on the top level, you could say what happens first is initial compromise. So in case of Tesla, the initial compromise was they opened up the interface that was published on the internet, and then initial compromise had happened. So the bug there was it was a configuration mistake. Then what usually happens is what's called lateral movement. So imagine that the attacker establishes a foothold in the system. He found one weak spot where he can basically do something. And then from there on, he tries to move further. And that's what lateral movement describes. A simple example, they are also connected to the Kubernetes world. I think 2 years ago, there was a bug in a container runtime that allowed an attacker to break out of the container and run code on the node, on the Kubernetes node with root permissions. So that's, of course, really, really bad, right? Because in this example here with Tesla, that would have caused them to basically own the entire Kubernetes node. So that's lateral movement. And then what happens in the end is they cause harm. They install a crypto miner, they steal some data, whatever it is. But that's typically what goes on when these attacks happen. And I mean, it's probably obvious, but what is in the way there is lots of bugs, right? Because if there wouldn't be a bug anywhere here, there would be no exposure to any attack, right? And the goal of the attacker is find the bugs, use them in a way that is useful to them, and then break into the system. That means basically what an attacker does, it tries to find initial foothold, and then he finds his way through the system until he finds something that is useful for him, or where he can install, as we said before, a crypto miner or whatever. So this is probably all very obvious, but I just want to highlight we're talking about simple software bugs, right? So there is no special security notion to that. We just need to make sure that we limit the number of bugs in the system, and then we will limit the attacker in his movement, and that will have an implication on the time he spends on the attack and the money he can make with that. So moving on there, what to do? We simply reduce the bugs, simple, right? So we just get rid of all the bugs. That means more work, less crime. So as simple as that. But how do we do that? And it's also obvious, right? But I took the definition here also from the CNCF latest cloud native security white paper, also a good read. I can recommend that. What they say is there is this well-known 4 phases during development: develop, distribute, deploy, and runtime. And the new thing in cloud native is that security is injected throughout these distinct phases instead of bookending the lifecycle with separately managed security-informed interventions. And what this kind of complex sentence means is, in the old times, you were working on a product for like a year, and then 2 months before the release happened, somebody said, let's do a system test, and then let's do a security review. And then the experts came in and did all kind of stuff. Then they gave their green check marks somewhere, and then you were good to release the stuff. And of course, many misses occurred there, right? Because the system was built, right? It was already done. At the end, you did this security check, and the system wasn't quite perfect. So you did a few patches here and there. But I mean, actually, the architecture was broken. So the whole idea is we need to move that earlier in the process. And how do we do that? Can we do that by simply spreading security professionals everywhere? No, we can't, unfortunately. There are not enough security professionals, and typically security professionals have a very different profile from software developers, and it's very hard to make sure that security professionals get the exposure to newly developed software very early on in the development process. So we need to find another way there. So in other words, we need to have everyone contribute to security all the time. And that's also, I mean, a bit like with quality, right? So, I mean, nobody, I think, in this room would argue that it's not the responsibility of a developer to write unit tests. And in the very similar view, I see also security. I think this is something that everybody needs to have on its mind. And this is simply one thing we also need to do together. So that brings in, obviously, and some of you might have expected that already, the very famous mantra of DevSec Ops. I'm honestly not a giant fan of keywords, but that's the one I actually like because it underlines what security guys want since a very, very long time. They want to be part of the development process and not be like an add-on that happens at the very end. So DevSec Ops for me really means that the security teams enable the development teams in order to do so that security can be done, and the security teams set like the constraints, the properties of the development process, you could say, in order to make sure that the developers have some goals that they can relate to. So enable the developers, make them aware, that means also training, and then we need to define measurable security targets in order to make sure that we're all on the right track. That means, in other words, we need to scale security, right? So it's not anymore a topic of the 15 guys in the security department, but it's something that relates to all the 500 guys in the R&D environment. So what do we need to solve there? And this is largely, at least for me, not solved. So this is, I think that we have a lot to do there with regards to tooling. I think we need to aggregate and abstract information. We need to pre-analyze and advise. Nobody has time to look at raw data. That's a mistake that I think many security tools of the past did. So here are 500 alerts, go and read them. So we need to change the way we think there, and we need to change the way tools operate in this world. And of course, we need to make sure that we automate everything possible, because simply we have no other choice. We have too little staff in order to make perfect security happening with only manual effort. So we need to support everybody dealing with the complexity. And that's also relating back to what I said in the beginning. So how do we deal with the complexity? And I'm trying not to link over to artificial intelligence. And this is the way I think we very often did our AI in the context of security in the past. And this is not the way it's useful. So the general idea is of this cartoon here is you just feed whatever stuff into some magic algorithm and it will tell you the right answer. And if it's not the right answer, well, I mean, you just tweak the algorithm and shake it a bit until it does. And then you eventually get the right answer. So that's not useful. And that's, I mean, it's obviously exaggerated here, but I also think that this is a misconception that in the way how we could make use of these very advanced toolings there. So what do we need instead? I think we need artificial intelligence to scale human work. What does that mean? I think we know that we have all much more to look at than we can potentially look at. So we need to make sure that we automate the stuff we have no chance to actually cover, and at the very least, get rid of all the repetitive, tedious things that are in our way. And AI can be a way there. And that also means to me that AI doesn't need to be this kind of magic machine that does things that no human would ever be able to. But at the very least, it should simply do the stuff that only 1,000 of myself could do, right? I just want to scale myself in order to make sure that the right things happen. And one important thing there is we need actionable findings. So in the past, what happened very often was that you had a machine learning algorithm that said, classifier X considers event Y anomalous. And that's it. That's what the system gave you. And then you are left alone figuring out whether this has any impact on your environment or what you should do with that or interpret it. And that, of course, I mean, it stops short of this whole idea of DevSec Ops, because with DevSec Ops, the alert is not the end. The alert is just the input for the next stage in order to drive forward the process. And that means it needs to be actionable. There is a new trend that's called explainable AI that some of you might have heard of. And I just copied, for those of you who haven't, the definition from Wikipedia, which I actually find stunning when you look at it. It's like, just quoting this one sentence here, in which the results of the solution can be understood by humans, which implies that for all the other things, they cannot be understood by humans, which brings me back to my initial point. What is the value then? If I just know that there is an alert, but have no means to interpret what it means to me or take actions from it, I wouldn't simply know what to do with that. So bringing that to my point, security requires automation, as I said before, and we can use AI for that, but automation requires trust in AI findings, because otherwise it's useless. And there's a second point I try to make. We need a very, very low number of false positives there. And why is that? It's a very simple calculation there. So assume a false positive rate of whatever algorithm of only 0.1%. And now assume there is 1 million benign events per day, which is, I mean, not an accurate number, of course, but a realistic number given the size of the events, the systems we're currently monitoring. So that means that out of the 1 million benign events with the false positive rate of 0.1, you get 1,000 false positives, right? So relatively speaking, that's not much. But there is no way that your staff can handle this sheer number of events. There is no way you could even look at all that. So the typical reaction there is people look at that and ignore the results and just ignore the results going forward in total, right? Because they feel that there is no value for them in the system. So the limiting factor in these things is the staff that investigates. It's not the number that is written behind the false positive rate. It's the number of people you have that are able to deal with the alerts there. Because if it's too many, I mean, they will be overloaded and there's zero value then. Okay, moving on. My last slide, takeaways, and I think I'm at the end of my time anyhow. So takeaways. I think my main point here is I want to say security relates really to quality, and every bug less matters. It's not about this one security incident that we need to fix after it became known, but it's really every single bug, because as I've tried to show you, attackers navigate through a system by means of bugs. So we need to make sure that we get rid of those. And input validation and error handling, I mean, it's boring and old and everybody knows that, but this is really essential and everybody should have that on his mind. Don't assume that security guys got you covered. I mean, they have no chance to cover typically all the stuff that happens in an organization. It's your job as well. So everybody needs to be aware. Then always assume that vulnerabilities are everywhere, because with all this complexity in our system nowadays, there are vulnerabilities everywhere, in the container runtime, in Kubernetes itself, in libraries, in the custom code you're using, in the operating system, everywhere. So make sure that you use as little external code as possible, right? Because I mean, the less code you're using, the less stuff can be vulnerable. And also, of course, you need to update frequently. And I know this is very, very much a trivial thing to do, but given the complexities of applications I'm seeing, where hundreds of libraries are pulled in for no particular reason, I just feel that this cannot be said often enough. So next thing, attackers require information, right? So imagine again this picture. They navigate through the system. They try to find out what is the next step that provides value to them. So don't give it to them. Don't give them version information as part of whatever responses. Don't give them overly verbose error messages, hinting at what should have been the input in order to trigger a certain reaction. So don't do that, because they will exploit that, and that's always a bad idea. Then my favorite topic is, I think it's not about tech. I think it's mostly about collaboration and knowledge sharing. I think these are the single most effective measure. So that means I'm a giant fan of code reviews for various reasons, also for security. And I think we need to have efficient bug workflows, right? So that hints also at collaboration. I mean, you all know these stories where a bug is moved from one person to the next for 3 weeks, and that doesn't help security, right? So we need to make sure that we all look at that and improve the bug workflows as soon as we can, as quickly as we can, to speed up remediation processes. And my final point is, and that's actually a message I actually want to send out to senior management. Companies need to find a way to reward quality versus just speed and functionality. I think this is a root cause for many of the problems we have been seeing in the past. Because the 2 examples that I showed you, those were not really rocket science. I mean, that didn't require a hell lot of skill to break into there. It was just overlooked. And I think with all this trend to move to cloud native and pushing out feature after feature, we need to remind ourselves that quality pays off, but maybe not instantly, but over time when there is less security holes, no data breaches, and so on. And now, once again, bringing up my opinion again. So I hope I managed to explain why I think that engineering scrutiny is really at the core of improving security. And also, I tried to explain briefly, what I mean by helping humans with complexity and how that could improve security. And that's all I had. Thanks a lot. And of course, I'm open for any questions.
Thank you, Andreas. So no questions so far. If you look into the chat, I posted the link. Yeah, the first one is here. So please go ahead and ask the question. I'll just read out the first one. So regarding involvement of security ops, right? Shouldn't there be at least one SecOps engineer in, streamlining, how to approach that, and how should that start?
That's a very good point. So that's right. So there should always be somebody who is basically driving the process. But what you should be aware is the dimensions we're talking there about. So there is reports that show that how much shortage there is of security staff, right? So there is simply not enough staff out there to have one of these guys, let's say, in every team. So that's not the scale we're talking about there. So imagine there would be one security guy per 50 developers or so. And then that also hints at what he can do. He can set up the tools, he can get the right tools bought, he can train the developers, but he will not have time to look at much of the details unless the very high level alerts or anything like that. So the workload really needs to happen in development, because otherwise we have no chance to scale.
Okay. So another question came just in. What tools would you recommend running minimum security checks in source code? So thinking of pipelines and also integrations that could be easily, set up.
So of course, the first one coming to mind is Dynatrace application security. Just kidding here. But so I start from the very first part. So we one thing that has a lot of value are SAST scanners, so static code analyzers that very often nowadays run directly in the developer IDs, are very advanced, but only can cover a certain subset of things. But the big advantage is this is often a pre-merge or pre-commit check even, right? So this catches things very, very early on. Then you need to complement these things with some kind of dynamic analysis, because certain vulnerabilities you can only find by actually executing the code. That means that there is DAS scanners, there is RASP, which is runtime application self-protection, which is also a direction where Dynatrace is going to. Then you certainly should have an eye on the third-party components you're using. That's an absolute must-have. I mean, there are statistics that say that, I don't know, 70 to 90% of application code is coming from third parties. So you cannot afford not having an eye on them. And that also means you need to have a great data source, right? So you need to understand what are the vulnerabilities out there. And if you just rely on bad data source, you can have the best tool in the world, but you still will find not all the stuff that matters. And then final thing, I mean, there's many more tools, but the final thing I'd like to mention is, in my opinion, you need to have some kind of runtime monitoring as well, simply because developers usually don't know where this particular build is running and what implications the environment in which it runs has on the security of the service that's running and or the data that is sitting there. So you need to merge these views. And that's also hinting back at what I tried to say before. We need to create visibility and remove this kind of complexity and explain to developers what is important and what matters. Sorry for the long answer.
Thanks. Another good question. How may a manager reward quality over quantity? Or phrase it in another way, how can I convince my manager to invest in security in that sense and quality?
Yeah, that's a very good question. I think this is actually something that needs to come from management. So I think that managers need to tell developers that quality matters, not the other way around, because it's in the end it's an investment strategy, right? I mean, by nature, management could decide we ignore quality, we just put on speed because this is simply what matters for us. And then developers have no chance to push through with this requirement. So I think this is something that the company needs to establish, like at the top level, to make sure that quality is really something that everybody wants. And that brings up the questions: how do we measure quality? And that's also a very hard one, right? So there is of course code coverage statistics which can be used to provide some kind of baseline. So we used in the past guidance that we wanted to have 70% code coverage on all of our unit tests. But that's, I mean, it has to be taken with a lot of grain of salt, right? So it's very hard to come up with qualitative measures with quantitative measures of quality. I don't have a good answer there. We need to discuss that and find individual solutions.
Okay, so it's about communicating the needs, both directions. You say there needs to be involvement from management and buy-in from management to get that going.
Yeah, that's what I'm saying. Yeah.
So another interesting question. Yeah, now we have AI to assist us in terms of identifying, security issues, etc. We are using that, but won't that help attackers too?
Sorry, I didn't quite get the start of the question.
Yeah, we have AI to assist us in identifying those security issues, right? Internally now, think of, applying AI to identify vulnerable code, for example. And then won't that same mechanism, AI, help attackers too to identify, loopholes in systems, for example?
That's a good thought. Potentially it does. I'm answering with my point from before. The problem of a defender is that there is more events than he can potentially deal with, right? So my main benefit, or the main benefit I see in AI, is to scale the defenders, basically. I would say that attackers very often don't have the need to really do that. I mean, they fight an unfair battle. They're alone, can try to explore whatever they can. But of course, I mean, it's probably not really AI, but there's of course tools that speed up their exploration there. I mean, for example, that's not AI, just to be clear on that. But of course, there's tools like the burp scanner, which would automate scanning a certain endpoint for input that would be accepted, for example. So of course, that speeds up stuff, and you could imagine that putting AI on top there would probably improve the speed of these kind of tools. But I don't see the particular need on their end so much as on the defender side.
Okay, we have another 4 questions. So what trainings would you recommend to start the DevSec Ops role in a team?
So the first thing I want to highlight, or I want to link to, is the OWASP, the Open Web Application Security Project. So they have lots of very interesting tools, but also very interesting documentation on what attacks exist and how to defend against. There are, for example, the OWASP cheat sheets, which, for example, give you like a Kubernetes security overview. What are the typical attacks on Kubernetes, and what should you defend against? So that helps already a lot. But I mean, I'm knowing that we all have too much to read. I really think that that collaboration and talking to each other is the best way to exchange knowledge there. And I think one culture that I absolutely would support in the company would be if the security team, the specialists there, would simply occasionally give talks on new interesting findings, or even look at stuff they found, problems they found in the existing code, and discuss it with the wider team in order to give everybody a chance to learn something.
Thanks. Maybe you post that links, the OWASP, so that people can get started in the chat, so that we have it there. That will be awesome. Okay. Yeah. Do you think it is necessary to have dedicated security people, or do you think it is a good enough idea to increase the normal dev security knowledge?
Yeah. I would say it depends on the size of the organization, because it's also a matter of affording these guys. I think that from a particular size on, you absolutely need to have experts that are familiar with, so that have the necessary foundations in security. So like a study of information security or anything like that, because very often you will need that in order to better understand what's going on. So that's simply speeding up the process. Also, I think you need these guys because much of what concerns security is not about actual code work, but it's actually about process and keeping track of security and focusing on the right things. And I think developers with their background are not a great fit for that, because as I said, they lack the foundational skills in this regard typically. I mean, not saying that not developers can grow in this role, but I think it requires a different skill set.
Yeah. This also connects to the two questions that are open now, which is mainly many developers, they are just not aware of the security risks they might introduce, which connects to what you just said. Are there best practices to build up that knowledge? Is the OWASP page maybe a good starting point? The information you can find there.
Yes, absolutely. So the OWASP is a great starting point. So there is many different kinds of information there, and I could even provide more links, but I think OWASP will already provide plenty. But in the end, I just wanted to highlight again, it's many security challenges relate not to specific security magic stuff, but to really the old stuff that everybody should be aware of anyhow, like input validation. I mean, this comes up very at the top, usually in all the reasons why a system was broken. So I would simply say following good software engineering practices is already a very good start. And I think having in mind that writing this unit test is not only for quality or making sure the system does the right thing, but it's also a security measure. I think that always helps to keep in mind.
Cool. And then the final question is connected to the financial aspects of the training effort. Is it even feasible to train all software engineers in a team on that techniques and security, values?
So I think it's not trivial, but I'll try to say, for me, it's the same as with quality, right? So there is a certain level of understanding every software engineer requires about quality and how testing works and so on. And for security, I think we simply need to establish the same. But of course, having said that, that doesn't mean that developers are generally going to be security experts. It's just what I tried to do in this talk here is I just wanted to raise awareness that good engineering standards also help security, and that alone I think helps very often to avoid security problems.
Great. This being said, I think that's a great closing to your talk. Andreas, thanks a lot for that interesting talk. Thanks for taking the time to present it to the audience. Maybe we have the chance to do that in person again on another topic here in Klagenfurt in 4 months from now. That will be awesome.
I'd very much hope so.
Cool.